The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Welcome to January's session of the Virtual Performance Chapter. Glad you all could attend today. This will be a fun one today. We've got Warner Chavez with us. I'm always excited to have him. And thanks for returning. And I'm going to go ahead and turn it right over to him. I know normally I have slides for everyone. I don't this time. I failed. But for February, I definitely will. So right over to Warner, and we're excited to see what you got for us today.
Thank you, and thanks everybody for joining us today, wherever you are in the world, for another session of the Performance Virtual Chapter. So today we're going to talk about performance testing with the database Experimentation Assistant. All right, allow me to introduce myself, guys, in case you haven't been to one of my sessions. I've DBA and consultant for 11 years now, and I used to be a DBA at HP in Costa Rica. I am now a principal consultant at Pythian in Ottawa, Ontario. And I'm very honored to be a Microsoft Data Platform MVP. Feel free to reach out to me on Twitter at warchaff. If you guys want to check out my personal blog, it's sqlturbo.com. If you want to shoot me an email, go ahead. It's warner@sqlturbo.com. And if you also want to check out my company's website, is pythian.com. We have a lot of good technical content there at Pythian because we also have a technical blog there. I have about 4 other colleagues that are MVPs as well, and we all blog there every now and then, okay? All right, so let's talk about the agenda for today. What we're gonna do is basically an overview of the Database Experimentation Assistant tool from Microsoft. This tool was released last year. It's a very simple, very fit for purpose tool. You know, it was built to do one thing, and you know what it's built to do, it does it well. We're going to explain what it's useful for and a couple of examples that I ran on my Azure VMs with SQL Server, and show you guys what the results were and what you can expect to get from the tool. So we're going to go over a little bit of just basic performance testing concepts. We're not going to spend a lot of time with that. Then we're going to go into my VM and check out that tool and what the workflow is with the tool. I do want to touch on a little bit about how the tool compares to Query Store, because you know sometimes people think like, oh, Query Store can it be used kind of like a performance testing tool or not? So we're going to go into a little bit of detail about comparing the two of them, and then we're going to do a couple of demos. We're going to do a performance test where, for example, I wanted to determine if enabling page compression would be a good choice for a particular table. And then we're going to do another test where I want to see the performance impact of going from 8 cores to 4 cores in a virtual machine. And for this, the prerequisites really for today's session is, I mean, if you guys are here, I know you guys have SQL Server experience, so I'm really not worried, because really that's all we need for today is just, you know, if you know SQL Server, then you're probably gonna understand everything in the tool, and you're probably gonna be able to just, you know, fire it up and running after you watch the session. So let's talk a little bit very briefly about performance testing and, you know, why we're all here. Every single person in this call right now, I can see there's 179 attendees. Every single person here at some point will be asked to do some performance testing. Otherwise, you're not really a production DBA. Why? Because it's all about decreasing risk, and for most shops, performance is either 1 or number 2 priority. This is a small tangent, but most people would say security is number 1 priority, but I know some places where even performance is more important than security sometimes. So it's very expensive to do performance testing if you do it incorrectly. What do I mean by that? Let's say that your company is running a production SQL Server, okay? And they're running a SQL Server Enterprise with 8 cores on a box. And they're having some really bad performance issues. And they come up to you and they say, hey, Bill, we're thinking that really the fix here is to go from 8 cores to 16 cores. And that way we're gonna hit our projected growth numbers for next month. And then, you know, we all believe in the idea. We go out, we buy more chips, or we actually provision a larger VM, and then we buy the licenses for the extra cores, or we take them out of our enterprise agreement and increase our engagement with the Microsoft. And it turns out that when we actually go and try it out, and the next month's peak came, it was not enough, and we actually just did all that investment and fell flat on our faces. So it can be very expensive if we do not do performance testing correctly. And it's just not expensive, not just for your company or your employer, it can be very expensive for your reputation as well. It is time consuming if we do it with manual approaches. So if I go one by one and just go ahead and fire up Profiler or extended events, and then I pick all the little events that I want in it, and then I think about which ones I really want, and then I have to figure out a way to read the trace and normalize it, and then I have to figure out a way to compare them between the two of them, right? There's a lot of steps into it. So this is where really the tool here, the DBEA, shines. And it's the one thing I can do say about it is that once it's set up, because I did have some difficulty setting up, but you guys are going to learn all about that, so you don't have to go through the pains that I went through. Once it's set up, it's very smooth and fit for purpose. You're in, you're out, and you got your results. So performance testing in general, there's different types of performance testing. For example, there's quality of service testing, where usually it's based on seeing how well the entire system responds, especially through the network, and making sure that everybody's getting a fair slice of the pie of the resources. Load testing is when we try to simulate, or we actually capture a live workload and then try to see how the system will respond under load. And then there's also A/B testing, where we capture a baseline and then we do a change, and then we try to see what the impact was of that change, right? So this is what the DBEA tool really is built for the A/B testing scenario. And that's fine, because it's a very common scenario that we run through when we do performance testing, right? So the idea here of A/B testing is that we have two versions of something, and they are usually identical in every way except for one variation. So I want to stress that point, because a lot of the times what happens is that people start to try to throw things at the wall and see what kind of sticks. And then when something sticks, we don't really know exactly what was it that did it, right? So sticking with this workflow where I measure a baseline and then I measure against it with only one variation helps us avoid this common issue of, well, what change did we make that had this impact? And sometimes it's even positive, right? We're like, oh man, it's so much faster today. So what do you do? And you're like, oh, well, we did this and that and this and that. And it's like 3 or 4 or 5 things at the end. And yeah, it's great that it's run faster, but which one's the one that did it, right? Are we paying some extra overhead on one of the other ones that we just don't know and we don't even really need it? But it's already deployed and it's running faster, so we don't want to touch anything. And that's in the positive scenario. In the negative scenario, it's even worse, right? We deployed 6 things, again, trying to throw things at the wall, and then it actually got slower. And now what do we do? Do we take all 6 back? Do we just take 3 of them back? And so on, right? So definitely you want to stick with, one change at a time. And A/B testing, this very simple idea, is very common and useful for all sorts of performance related scenarios, right? For example, if we're moving from one version of SQL to another, that's a really big deal, especially let's say if you're moving from a SQL 2008 to a SQL 2014. If some of you guys here in this webinar have had the experience of doing that, I'm going to bet that some of you got a little bit burned by the differences in the optimizer that were added in SQL 2014 and the new cardinality estimator, right? So what happened there is that because of the new rules in the cardinality estimation, some queries actually regressed when they were upgraded to SQL 2014, even if they were upgraded to bigger or better hardware, right? So anytime that there's a movement there from one version to another, especially when there are new components being added to that version, like in SQL 2014 with the new cardinality estimator, it's very important to be able to test it. And this is a very simple A/B test, right? We capture a workload in, let's say, our SQL 2008 machine, and then we capture it, we replay it in the SQL 2014, and with a tool like DBEA, we would be able to compare the results of both of them, right? If we're doing a code change. So this one is a little bit trickier if you're going to do it through DBEA, because DBEA is going to match the queries by their code signature, right? So if you were rewriting a query that gets executed ad hoc by an application, then that is going to be a problem, because DBEA, you know, let's say you capture the workload in your production that has version A of the query, and then version B of the query actually is a rewrite of the query, then DBA is going to flag it as a new query, right? So for some of you here in the webinar, you're probably already thinking, so what I need to do, or if we're going to do that, is to wrap it through a store procedure, for example. That's the way that you can do a code change comparison, through a store procedure signature. You can't, ad hoc is not going to work with DBEA, because again, the code signature is gonna change. Okay. Index changes, definitely you can do it with DBEA, because the query itself is not going to change unless you were changing something like a hint that's going to actually change the query text. But if you're not, then you can definitely test, you know, your production workload, and then you replay it on a copy that has the different indexes. This is very valuable, not just when you're adding indexes, but what is one of the biggest fears that every single DBA has is when we think that an index is safe to drop. And then in the back of our heads, what we're thinking is, what, oh man, and what if it's still being used? Oh, what's going to happen? Is this going to tank tomorrow? Oh, and then it's a reason why a lot of people don't drop indexes, even though you know the DMV says nobody's using it, and you still don't want to do it because you don't know how it's going to hit your workload, right? So DBA can definitely help in that scenario. And if the index indeed you should not have removed it, then you're going to know, because your results are going to show that it is going to be degraded, okay? And last, if you're going to activate a feature, this is very similar to, for example, doing an index change. Simply you compare against a workload where you activated the feature. Maybe you were activating column store indexing, maybe you were activating query store even, and you were scared of the load that the query store is going to put in your system. You can do that. And the one you were going to use in the demo is page compression, by the way. Oh, and I skipped one here, which is doing a hardware or virtual machine config change. Very common as well, right? So let's say you want to see the impact that it's going to have on your workload if you have new storage, or the impact it's going to have if you build up with more RAM, or if you add more cores, and so on. Okay. So the workflow for the tool is very simple. It's nothing, like I said, it's nothing exotic. You just do a capture, and this capture is done through Profiler. Now you guys might be thinking, somebody else in the webinar might be thinking, well, why isn't it done through extended events? I have no answer to this question other than the team is supporting versions from 2005 until 2017. So my only answer I can say is that obviously if they were doing 2005, they would not be able to support with extended events. So the fact of the matter is that the capture is done through Profiler. So second, the replay. So the replay is done with the distributed replay tools. So you're gonna need a version of SQL that has the distributed replay tools. Now the good thing here is that Developer Edition ships with the distributed replay tools. So all you really need there is the distributed controller and a distributed client. That's going to be the one that replays your profiler trace. And like I said, Developer Edition ships with it, so you can always install them from Developer Edition if you're just going to do some performance testing. I mean, the end, it's testing, so it's not a production use. So you can do that, okay? And third, the analysis is done with some built-in reports that DBEA comes with, right? And these built-in reports, they do have some dependencies, mostly on running R, and these dependencies can, if you don't have them set up properly, they can pretty much just break, and it doesn't generate any analysis like I discovered when I was preparing for the session. But that's the good thing, is that I discovered it, so you guys don't have to suffer through it. So in detail, what happens if you want to use the tool, right? So you trace your prod server. You want to trace during a time that is going to give you a significant workload. That is something that is it's going to capture what you're interested in, right? If you're interested in capturing the performance of your month-end reports, then you're not going to run it at at the middle of the month, right? And if your busiest time that you're interested in capturing is let's say 1 p.m., you're not going to run it in late at night then. The capture part, the trace that it runs as the captured part, is actually fairly light. And this is good because the idea is that you're going to trace your live workload, right? So it does a very light trace that you can deploy on the prod server, and that's how it captures your workload. Then the tool takes this very light trace, and then it creates a heavier one, and then replays it on a target. So the idea here is, we capture a very light workload from prod. Then we want to have a machine that is as close to prod as possible, and we're going to replay that, light trace, but it's going to add more events to it, right? It's going to add more events to it. It's going to be a heavier trace. Then that same heavier trace is replayed on target B, and that won't be the one with the change that we are testing, okay? So let's say I have prod server A, it's a SQL Server 2012, and I'm going to upgrade to SQL 2017. So I trace server A, SQL 2012, then I replay that trace, which is going to be a heavier one, on another SQL 2012, but this time it's a development one, so the trace can be heavier, and that's okay. We don't want to run the heavy trace in prod, that's why the workflow is set up this way. And finally, we replay that same heavy trace on, let's say we're upgrading to SQL 2017, right? So finally, that's what we replay. Once we have the results of those two, then we can compare and analyze with the database experimentation assistant, okay? So some gotchas things here that I wasn't expecting, and it took me a while. So you do need the distributed replay and control, the distributed replay controller and the client. The controller basically takes your profiler trace, but it doesn't replay it, right? It actually sends it over to a client, and then the client is the one that replays it. And the reason why it's set up that way is because you're actually free to add multiple clients, right? Let's say you have 10 web servers and you want to somewhat try to simulate that. You could have, you could have 10 clients if you wanted to, but you could add multiple clients if you want, so that the workload is parallelized and it's more real to the live scenario. And if it's a case where you just want to try out a feature or you don't really care about replicating exactly the full volume, then you can just use the one client that it in the one machine. I even had the controller in the same machine as the client. You need to install R for Windows, so you can go ahead and Google R for Windows and download it and install it. This I did not, when I installed DBA, I didn't find it that it said anything about doing this until I started to run into issues, and I started to search for blog posts online and people that had issues as well, and then it was like, oh, you have to install R for Windows. So yeah, you'd have to do that. Another thing, the installer for R for Windows, it's supposed to add the binaries path of R for Windows into the path environment variable of your machine. I run Windows 10 as a client, and for some reason it didn't do it, and so I had to add it manually. So that's another gotcha that gave me a different error down the line. If you guys run into that one, then that's good. I just saved you some time. And finally, the last thing that kind of bit me was that I created this fake workload with SQL query stress, and I'll show you guys in a little bit what was my whole workflow, so you can recreate it if you think the tool is useful. I'll show you guys what the workflow was. But there were some queries that were taking, they were taking like 5-10 seconds per query, so I didn't want to just wait and run a really long trace for them, so I only ran them like 5 times. And then when I ran the analysis, it actually came up with a thing that said, oh, I can't evaluate the performance of this query. And then I, reading on some blog posts about it, turns out that if a query has less than 30 executions in the workload captured, then the tool pretty much just says there's not enough executions here to give you statistically valuable data. It's just not significant enough to have only like 5 executions like I had in my initial workload. So it turns out I didn't realize that until I had run through the whole thing and got to the end and the analysis. And then I figured out, oh, I have to rerun it now, and I have to run it for at least 30 executions for every single query, right? So if you are not capturing just the live workload and you are trying to create it one, even if it's a real one, but you're trying to create it with like SQL query stress like I did, then you have to run it at least 30 times, otherwise the query is not going to be analyzed for comparison. Okay. All right, so let's jump into the demo and I'll show you guys what the tool looks like, and we'll run through what I did to set up my workload. Okay, so let me see. So here I am, this is my Windows 10 VM. I have SQL 2017 installed, and I'm using this, the database Experimentation Assistant 2.1, which is the latest release today. It was actually released about, I think it was like 20 days ago. It's the very, very beginning of January. Okay, cool. So very simple tool. It just, it just has 3 buttons here, the help and a smiley face for feedback. And as soon as you open it, it tells you, what you have to do, right? Is to get started, you capture a workload, just a little camera here, then you replay it, just the play button here, and then you can analyze it with the this thing that looks like a checklist here. Okay, so here's how it works. So you go here to captures, and then you guys can see here there's even not that many options. It just says click new capture for production workload and a plus button that says new capture. So we're going to do a new capture. We're not actually going to complete it. That's okay. It's just to show you guys. Okay. So what do we get here in terms of options? Let me zoom in a little bit and I'll show you guys what this is. So I have to give the trace a name, and I have to give it a duration in minutes, and that goes from 5 minutes all the way to several hours, right? So you just give it a name. I would advise something that you remember what is the database that you're trying to trace. In this case, the example says AdventureWorks trace. I actually use an AdventureWorks database for the test as well. But it could be, I don't know, whatever you're doing in your environment, right? The HR database, the Dynamics database, whatever. So that's the capture info. And then we just have here the SQL Server connection details. So we have to give it the instance name, if we want to encrypt the connection or not, if we want to encrypt the connection and trust the server certificate. And then we just have to say the database name that we are going to be capturing and the path to put that trace file result on SQL Server. And then finally, you guys see here, there's this button, this check that says, yes, I have manually taken the backup of target databases. Basically saying, you want to have the backup before you run the trace, right? You don't want to run the trace and then take the backup, right? So as soon as your backup is over, you kick off the trace, and that's how you do a capture properly. You don't do it the other way around, okay? Okay, let me get out of my Zoom, and then I could press start here. I'm not going to do it, and it would just start the profiler trace. Now, If you want to do like I did and run a fake synthetic workload, then you guys give me a minute here. Let me go to my downloads and find SQL query stress. If you're not familiar with this tool, it's super handy for demos and things like this. I use it all the time. If you are familiar with it, then great, you can use it. So what I did, for example, for this particular workload is I created 8 different queries that were running against the VentureWorks. And let me just make this a bit bigger. Okay. And so for example, this one, you guys see here, I'll just show you guys what it says. So it select from a big transaction history table. So that's a VentureWorks made bigger through a script. You can just Google big VentureWorks and you'll find the script. And a couple of orders so that it, it generates some work. And remember what I said about the amount of executions, right? It has to be over 30. So this was my mistake initially. Let me show you guys here. See, if I go to the settings that it had, it says number of iterations 7 and number of threads at 5, right? So total, that's 35 executions, which is what we want, right? Initially, because this was taking too long, I had it set to 5 threads with only 2 iterations, so that generates what? 10 executions. So because it's less than 30, I got the issue that my queries were not being evaluated by the analysis because it needs at least 30 to be considered statistically significant. Okay, so that's the gotcha there. All right, so that's SQL query stress if you want to use it to generate a workload. Then what I did was very simple, right? I had I'll show you guys. I had 8 queries that I saved on SQL query stress, and I had my capture running here through the database experimentation assistant. And then I just ran this one, I loaded the next one, I ran it, I loaded the next one, I ran it, and so on, right? And that's how I generated the trace for this workload. This is only in the event that you have to create the workload yourself, right? It's kind of like a synthetic test. If you can capture the workload directly from production, obviously that is better because it'll be real, right? And it will not be something that you manufactured. But I mean, if you don't have, if it's, I mean, I know this, that there's some places where it's hard to get permission to trace anything in production because of many different reasons. Or it's just, let's say it's actually, they want you to test new queries that don't even exist in production, so you don't really have a choice. The queries are not there in production yet. Then SQL query stress and just running them through here and tweaking the parameters here about the iterations of the threads, they're as good as it's going to get anyway. Okay. All right, cool. So that's what I did for the capture piece. Okay. Once you have a trace, then you can replay it. So let's go here. And it's the same thing. It just gives you basically, one-liner instruction, click new replay to replay a captured workload, and it just has one button, and that's it. So there's not a lot that you can be, you're gonna get lost. Couple of things here. So let me zoom into it so we can see what the settings say. Okay, and so it's a replay name. So again, you just give it whatever name you want. Then it has the controller machine name. So this is the machine that has the distributed replay controller. The DBEA, it does not do any sort of setup of the replay controller for you. So this has to be set up and configured by you, by the way, okay? So actually setting it up and configuring it is, I would say, it's out of scope of today's session because you can find lots of resources online. It's really easy. You just have to install the replay controller and the client with the SQL Server media. Then you have to configure the client to connect to the controller, and then you just have to tweak some DCOM permissions. And if you Google, distributed replay controller, SQL Server, how to install, you'll find all those instructions there. you have to give it a path so that the controller can find the trace that we generate on the capture. And then you just have to tell it where is it going to be played against, right? So here, same thing. It says the SQL instance, you pick the same connection settings, you pick where to store the target trace file on the SQL machine. So this is the heavier trace that we talked about in the slides, right? So in the capture step, we captured the light trace. Now in the replay step, the whole point of the replay step is that it takes that light trace, runs it through the controller, and generates this heavier trace. And this is like the replay trace. This heavier trace is the output of this step, right? So it's kind of interesting because output of capture is a light trace, and then the output of replay is a heavier trace. And you're gonna have to do this replay step twice, right? Because you wanna do it A, in the copy that looks like prod, that would be your A part of the A/B testing, and B, in the copy that has the one change that you want to test, okay? And same thing, it makes you acknowledge that you manually restore the database before you run the replay, okay? So I'm gonna get out of the Zoom here. And that's it. It'll kick off, it starts to, once you have captured your workload with SQL query stress or through a production trace or whatnot, then replay is really easy, because replay is just basically, you already have that light trace and you can replay it as many times as you want, right? So let's say you captured the workload and you have that light trace, and you replay it once against your A copy, the one that is just as close to prod as possible, and then you can replay it as many times as you want with just like, basically just one clicks here to start. And you can replay it against a copy of SQL 2016. You can replay it against a copy of SQL 2017. You can replay it against a copy of SQL 2017 using a column store, using in memory, whatever, right? So really, the replay is really easy to get going with trying different things or testing different things once you have that first trace captured, okay? And then finally, the last step is just to analyze the traces. So what this does is that you have to give it let me show you guys. I'm just gonna connect here to the instance. So you have to connect to a SQL instance. And you guys can see I have 2 reports already created. That's gonna be what we check out in a bit. But I can also create a new report. And again, creating a new report is very easy. So all it does is, let me zoom in and show you here. So you have to just give the report a name. I would suggest something that represents the thing that you want to test. Then you give it a SQL Server instance. Now this doesn't have to be an instance of SQL that has anything to do with what you're testing. This can be any instance of SQL. I think it has to be only 2008 and up. And it's going to be using that SQL instance to store data from the traces and data from the comparison. And then here on the side, you can see is the 2 traces that you want to compare. These have to be the results from the replay, right? So the trace for target 1, which is going to be the one that you want it to be as close to prod as possible, and trace for target 2, which is going to be the one that has the one thing that you want to test the change on, right? So either the higher version or the trace from the machine that has the new storage, or the trace from the machine where you did the index changes, and so on. Okay, cool. So that's pretty much the entire workflow of the tool. So we're gonna go back to the slides, and then we're gonna come back and check out the results of some of the reports. Okay. So something that again can be brought up by people is, how does database experimentation system relate to query store? Because it also seems like query store captures what is running and then allows me to compare. So on the surface, it sounds like they are similar, but when you think about it, they have very different actual practical uses. Okay, so DBA is going to be for specific A/B tests, right? So you would only use it when you actually have a specific use for it of something that you want to test. You wouldn't just have it running all the time or tracing and replaying all the time, right? Query Store, on the other hand, you enable it and it becomes a continuously running daemon inside your SQL server, right? With DBA, because we are targeting a B scenario, a specific B scenario, then you know what is changed, right? You're the one setting up the test, so you know that you're either testing the new indexes, or you're testing the compression, or you're testing the new storage, and so on. Query Store, it could be that there's some changes that happen to a query that generated a new plan, but the cause of that change is unknown, right? Query Store is not going to tell you that the plan changed because you added some new CPUs or something like that, right? If the plan changed, it's just going to show up as, oh, we have a new plan here in the Query Store, and then it's up to you to figure out what happened and unwind like the reason for that the plan change, right? DBA is I would suggest to use it as a proactive measure. So if you have any sort of big change happening, or you have any sort of upgrade coming up and you want to do your due diligence, then you would proactively go in and you know, set it up, capture the workload, and so on, right? Query Store, on the other hand, is different. It is something that usually is used reactively, where you just want to force a plan to run, right? We have a query that's gotten slow, so we're going to go and analyze through Query Store, see if we have a better plan for that query, and then we either figure out if we're going to improve the query, or we just, you know, fix the problem with the hammer and just say force the previous best plan, right? And finally, DBA, it tracks the differences in execution even if the plan is the same, right? So DBA is going to find plans that are similar, not plans that are similar, find the queries that are similar, and even if the plan stays the same, it's going to give you a comparison between the A test and the B test, right? On Query Store, if the plan does not change, the stats for the plan in particular can get better, but it's not going to tell you exactly when that happened, right? So for example, if you added some faster storage and the plan for the query stayed the same, but it just started to execute faster because the IO started to respond quicker, then that's not going to be readily apparent with Query Store, right? So I hope this is a good comparison, gives you guys a good idea of the difference between the two tools. Both tools are very important. If you have SQL 2016 and up, I definitely, especially, I mean, we're in the performance chapter, so we're all interested here in making our instances run as fast as possible. If you do have Query Store available, I recommend you enable it anyway. And if you are you have a good environment where you can run these DBEA tests, then I recommend you do those as well. Okay. So let's check out the results I got for scenario number 1, and that was activating a new feature. And basically, we're going to run a comparison here of workload impact by activating page compression on the largest table in the database. Okay, so let's jump into the VM and see what we got as the result for that, and show you guys the analysis interface. So let me go back here and page compression, and let me make this bigger. Okay. So hopefully you guys can see it right now. So what is here on the screen right now? So you can see on one side is a graph that says query distribution, and sorry, both of them say query distribution, but on the left side, the one that my mouse is over now, it's by execution count. So we're able to see a count by the amount of times that they were executed, if the query is degraded, improved, if they were not evaluated, or if they stayed the same. And on this other pie chart here, we're gonna see if the query by distinct queries, not by how many times they were executed by, but but by how many queries were either degraded, improved, cannot be evaluated, or they stayed the same. In this case, when I enable page compression, we can see that, let me mouse over this guy. And then it gives me, for example, I clicked on degraded, so we can see page compression degraded. We can see all these queries that actually degraded in how long they were taken to run. So for example, I have this a select name product number from big product, and the mean duration on target one, which was my original without page compression, was 547,000 microseconds, and on the page compressed, it was actually 735 microseconds. So I took a hit there of 188 microseconds more when I had page compression on. And as we go down this list, we can see all of these are the ones that actually degraded when I activated the page compression, right? I can click on one of them, so let me do that. And when I click on one of them, it takes me into a detailed view of the comparison. So I get the text of the query. I get to see if it was degraded, the same or better. You guys can see here the category, and then it gives me a summary of the statistics for that particular query. In this case, you can see, for example, let me zoom in so you guys can see. So it gives me the amount of executions that this query had inside the trace, the mean duration inside the trace, how much CPU they used, how many reads they did, and so on, right? It also gives you a couple of some nice charts here in terms of duration, one versus the other. So we can see target one, the duration clearly lower than the other one. Target two, CPU as well. Clearly, we burned less CPU actually. What else do we have here? We have reads and we have writes. In this case, there's no writes because it was a read-only workload. But these graphs can just help you find, they can give you a guidance as to what the cause could be of why one thing was running slower than another, okay? Then I can pull out the query plan information as well. Now, the only unfortunate thing here is the execution plan. If you're not used to text execution plans, unfortunately, that's what you get. It does not have a graphic execution plan in the interface, okay? So going back into the home page, finally, there's this little drop down here at the top that says threshold. Let me zoom into it. Okay, so you see that threshold value there? It says 5% right now, right? So what that does is that it tells the tool basically, look, if the query is faster by 5%, then consider it improved. If it's slower by 5%, then consider it degraded. If the change is within 5%, then consider it the same. Okay, and that's actually makes a lot of sense because there's always going to be some noise variations and subtle things on machines that can change the execution times by small amounts. I mean, it could be that you had the antivirus decided to kick in for a couple of seconds when you were running a trace, or the machine suddenly just paged some other application really fast while you were running the trace, and you don't want it to be exactly say one query ran slower for 1 microsecond and another query ran faster for 1 microsecond, and then the tool is just going to say, oh, this one's slower and this one's better, because that would not give you actual significant results, right? So that's the threshold. This threshold can be manipulated. So let's say I was interested in bumping it up, I can actually go from, making it harder or more sensitive and say I want to move to a 1% threshold. So things will either be degraded or they will be the same or they will get worse based on a 1%. Or I can make it bigger and say, I want to do 15%. So for something to be declared improved, it has to have bettered by 15% as opposed to by, 1% that I was using. In my practical experience, I would say 5% is actually very realistic, and I wouldn't touch the value necessarily. I could just leave it as 5%. Okay. All right. So let's go back here. So that was scenario number 1, and now I'm gonna show you guys the report for scenario number 2. And this one is testing a hardware change on a virtual machine. In this case, it's my VM running in Azure. And we're gonna see the impact of removing cores. So this is something that sometimes happens, especially in virtualized environments where people are trying to see if they can get away with taking resources from you. They're like, well, what would happen? Can you just give us back like two cores maybe? Or can we take away a little bit of that RAM because it seems like your server is really like overpowered or idle most of the times and things like that. So it's a good tool to prove what the impact is going to be if resources are changed, right? In this case, I actually moved from 8 cores to 4 cores, okay? So let me go back here and I can just, once you have the reports, then it's really easy to switch back and forth between them. So as you guys can see here, overwhelmingly, most of the workload was just degraded. Degraded is the blue, by the way, when I removed the cores, right? No big surprise there. But the important thing is that if you were to find yourself in this type of scenario at your job, you would have hard data that proves why you can't give back those cores or why you can't give back that RAM, right? And the opposite is the same. If you were to test with more cores and it shows you that a lot of the queries improved, then you have ammo to go and say, look, this is why we need 8 cores. I tested it on our dev VM, and look at the change that it made from the 4-core VM to the 8-core VM. You can show the report. You can actually click on it, and again, it'll tell you what the difference is, right? In this case, it was all negative because I went from 8 cores to 4 cores. So most of it is degraded. Actually, if I go back and I want to see the queries that improved, you guys can see the queries that improved have actually nothing to do with my actual real workload. So this is something that's also good to keep in mind. Unfortunately, the tool does not differentiate between, let's say, like user type of workload and the instructions that it runs itself to generate the trace. So you guys can see there the number 1 query has to do with the trace file, and then the second one is just to set statistics IO and time on to capture the IO and CPU stats. So it's basically noise on the analysis. You can just ignore it, right? The good stuff is in the other queries. In this case, yeah, you would definitely be able to improve. You go here and you can see, the vast majority of them degraded. And if you have one of them that's like a really important report, you can go into it. Same thing, we're going to load the full analysis. And we can see again the plan. Let's see the execution plan here as well. If sometimes, it could be that there was actually a change in the plan. So the text view might be easy to see if there's a difference. If not, I haven't tried to see if there's, I guess there's probably a way that you can extract it from the database, because this stores the results of the trace in a database, and then you could run like a diff on the text itself and see if there was a difference or not. If the plan is not super complex, you can just do it visually. So last, before we finish up today, what are we doing on time? We got about 10 minutes, which is good. This is what this looks like in terms of what it does for your SQL where you run the analysis, right? So let me show you guys real quick here. You guys can see I'm on the Object Explorer and Management Studio. Let me zoom in so you can see the databases. So remember, I ran a 4-course and a page compression analysis. And basically what it does is that it creates an A database for the replay and then a B database for the replay. So you can see at the very top, I have A for course. Oh, this moved, sorry. And here it is. So I have A for course, and then at the bottom here, I have B for course again. So this is where it saves the trace data. And then it also has another database where it saves the actual comparison between the two of them. Here, this one that says analysis for course. So I haven't played around with checking out the schema of these, but it's likely, there's probably a good chance that there's some good tables here that could give us some info for other reports if you wanted to really customize it, for example, right? So this is, we can see there's the analysis database there. It shows the batches and the errors for target A and for target B. It shows the plan data for A and B, and it shows summary stats. So you can, if you wanted to, let's say, diff the plans and see what a text step is different, you can probably do it by getting that data out of that table plan data A and table plan data B tables. So if you're the type of, you're going to use the tool to generate all this, and then you want to customize some of it, some of the analysis on top of it, it looks like it's fairly easy to understand schema. Okay. Cool. So that was scenario number 2. So finishing up today, recap what we talked about. Performance testing, it is complicated, and if you make a mistake, it can be a very costly mistake in terms of dollars and in terms of reputation. So it is important to leverage the tools that we have at our disposal. Manual work, you don't want to do this manually, setting up the profiles and then figuring out how to compare them and so on. Way better to do it with the tool. Once the tool is set up, definitely you don't want to go through the gotchas that got me. So if you want to set it up, definitely just check out the slides later and verify that you have those things that I mentioned. But once it's set up and running, it's actually really easy to capture and replay over and over and over. So it is a good tool for A and B testing. It's very recommended. I would say anytime that there's a significant change that you might do, you probably want to do a round of A/B testing. It is similar in concept, but not the same as Query Store. If you do have Query Store available, I would suggest you use them both. You use Query Store as a reactive tool and a tool that can help you fix and analyze query plan issues live in prod, and you use DVEA whenever this A/B scenario presents to you. Okay. And next time that you are faced with doing a production change, an upgrade, or migration, I would suggest consider using the tool. Think if it could benefit you in a way that it will help you determine the impact of a change properly. Okay. So we have about 7 minutes left. I don't know if we have any questions before we wrap it up.
We have lots of questions. Lots and lots of questions.
Boy.
Yes. All right. I'm going to run backwards just since that might be easier. And they keep coming in. The query plans captured are
That's
also
okay. All right.
are also estimated like in cache, or are they, or they would be actual plans?
Are the query plans captured, estimate? I believe these would be, I think these are estimated. I think they're estimated because I don't remember if Profiler has an actual event. I know Extended Events does, but I'm not sure profiler does an actual, to get an actual with all like the actual rows that flow through and everything. So it's likely that they are estimated. That would be my guess, just because it's using profiler. The runtime stats are not. So the runtime stats are true for what they are. So you can always say, well, the runtime stats tell me that this is degraded, and I'm going to look more into it, and at that point really run it and capture an actual, right? The plan most likely, if you just go by strictly what is captured there, it could be that it's not an actual, and it could be that changed, especially on newer versions now with SQL having adaptive plan and all that kind of stuff. So I would say go with the runtime stats first. If you see something obviously misleading in the plan, like, you know, it used a completely different index that doesn't even exist in one place or another that you were not expecting, then that's good. But if it's something really small on the plan that you think is making the big difference, then I would definitely rerun it to get an actual one from the box.
Okay. A couple different questions around Azure and Azure SQL Data Warehouse. So I'm just going to combine those a little bit. Does replay work with Azure SQL Data Warehouse? And also the other one was, hold on, let me find this other one. Since this requires profile, Azure SQL is obviously not supported. Do you know if the tool will be extended to support Azure SQL?
No, unfortunately.
Yep.
So the tool right now is SQL Server only, so it's not going to work with DW or SQL DB. I think it will be more likely that it will sooner support SQL DB. I actually, I was in Seattle when they introduced the tool at the past summit, and I asked the team about it, about Azure SQL DB, and they did say it was on their roadmap to put it there. I would personally like Azure SQL DB to be in there because obviously it would be a big thing to be able to test it in a migration scenario, right? You do an A test with your SQL Server, and then you do your B test with Azure SQL DB, or you do an A test with Azure SQL DB, and then you do a B test with Azure SQL DB, but on like a higher performance tier, for example. There's a lot of good use cases for Azure SQL DB support, so, you know, hoping it comes down the line. But right now it's SQL Server only.
Okay, fantastic. Let's see here. Lots and lots of questions, guys. We're not going to be able to get all of them, but I'll try to pull some good ones out here. Do you manually restore backups every time you replay with DEA?
So you don't have to manually restore because what you should do, or what I did, is well, if the workload is read only, then no, right? Because you're not going to write to it, so you can only restore once and then run it a bunch of times. But if you do have a workload that will be writing, then I think probably the fastest thing to do is to not necessarily restore, but to restore it once, detach it, so you have the data files, right? And then you just copy and attach. And then when you have to rerun the replay, at least you don't have to restore again. You only have to attach the original. And attaching, I mean, most of us here know attaching is significantly magnitudes of time faster than restoring again, right? I can see how you can do other things that are fancier. Like I know Redgate, for example, has a cloning tool where you can create clones of a let's say a master copy database. That would be like really like, you know, the Cadillac solution, because you could have just the one master copy, and then with this Redgate tool, you could just create a bunch of clones for a bunch of different replays, right? But I would suggest, you know, if it's a large database, you don't want to restore it every single time, then probably at least saving yourself the restore time by attaching a initial copy might save you some time.
Okay, fantastic. Just so everybody knows, this presentation will be recorded on the Virtual Performance Chapter website, and I will try to get that up within the week. There is a request for you to throw up your presenter slide again so that they can grab your information. And
sure. Go back to it.
I think a lot of these questions you probably covered with that information. They're very similar questions, just slightly different. There was one. There's so many questions. This is good. I've had issues using the one controller or replay server when it's already replaying another capture. How would you parallelize replaying multiple captures? If they were captured in parallel, would you be concerned or skewed to replay them serialized versus parallel?
Okay, so that's a good point. I believe even in the documentation for DBA, it warns you not to use one controller for parallel loads, because I mean, I don't even know if it's possible. You can always just have multiple controllers if you want to run independent tests, right? If you do want the parallelization of in one test result, you are going to have it in one trace file and with multiple clients. So it would still be one trace file, and you would have one controller, and you have the one controller with multiple clients, right? It would not be a test where you would have multiple controllers. I don't know if that would be even feasible the way the tool works right now, because of the workflow it uses. And it would generate a bunch of different, if you were to use multiple controllers, you would generate multiple replay traces, and then you can't really merge them easily to compare them at the end, because the tool only gives you the option to choose one trace file for target A and one trace file for target B, right? So right now, basically, the answer is you basically have to stick with, if you want some parallelization, you would have multiple clients, one controller. You can't have multiple controllers.
Okay, fantastic. Warner, thank you so much for joining us. I'm going to send you the list of the questions just so that you have them for the future if you want to, update your presentation at all with some of the outstanding questions.
Yeah, for sure.
Anybody out there, please feel free to reach out
stuff.
to Warner. Yeah, really good conversation, really interesting stuff going on, and lots of thanks. Okay, thank you much, everyone. Have a great day.
Thanks, everybody, for joining. Till next time.
Okay, bye-bye.